Alright, so this is the last part, which is titration. Okay, so titration is a controlled process of acid-base neutralization, and it is used to determine the concentration of an acid or a base where one of them, or where the concentration or the volume of one of them is unknown. We do this by using two key information that we know. The first information is that in neutralization, 1 mole of H plus neutralizes 1 mole of OH minus. That's why you get a pH of 7 after neutralization. Why? Because pH of 7, you have the same concentration of OH minus and H plus. The concentration of them is going to be equal. Okay, so when they are neutralized, pH is going to be 7. The concentration of H plus and OH minus are going to be equal. So 1 mole of H plus will neutralize 1 mole of OH minus. And the titration formula is MAVA equals MBVB. This is in your chemistry reference table and table T, okay? And if you're not sure what MA and VA mean, just look at these right here. These are the keys for what the symbols mean. MA is the molarity of H plus, which is the same thing as molarity of acid, because an acid will produce what is this? Sorry. Okay, an acid will produce H plus, okay, and the volume of VA is the volume of acid. MB is the molarity of OH minus, or the molarity of the base, because a base is a substance that produces OH minus according to the Arrhenius theory. Okay, and we're gonna use this titration formula for the questions you're gonna find are gonna be Arrhenius acids and bases involved. Okay, so for the formula that is given to you in the reference table, it's only correct if the number of moles of H plus ions produced equal to the number of moles of OH minus produced. So for example, if you have HCl and NaOH, when HCl is added to the solution, it will produce, let's say, 1 mole of HCl. It will produce 1 mole of H plus and 1 mole of Cl minus. And if 1 mole of NaOH is added to a solution, is going to produce 1 mole of Na plus and 1 mole of OH minus. Okay, so this formula will work if you have these acids and bases. Also, it will work if you have two H and OH in the formula. So if you have H2SO4, this is a strong acid when added to a solution. So 1 mole of H2SO4 will produce, see this 2 here? This tells you 2 moles of H2 will be produced. So 2 moles of H plus. Alright. Okay, let's do this. Okay. So 2 moles of H plus and 1 mole of SO4 2 minus will be produced. And for the CaOH2, since you see the 2 here, you're gonna, in 1 mole, if you add 1 mole of CaOH2, you will be producing, in the solution, you're gonna be dissociating into 2 moles of OH minus and 1 mole of Ca2 plus. Okay, so if the number of moles of H plus and OH minus produced are equal by the acids and bases, then by all means this formula will work. If the number of H and the number of OH in the formula for the bases and acids involved in the titration are the same, so here you have 1 H, 1 OH, here you have 2 H's, 2 OH's, then MA, VA, MB, VB will work just fine. The problem comes when the number of hydrogens or OH hydroxide ions in the formula are different. So, for example, here H2 here, you have an H2, two H's per formula. Here you have one NOH per formula, per chemical formula. So if you dissolve 1 mole of H2SO4, you will produce 2 moles of H2 of H plus. And if you dissolve 1 mole of NaOH, you'll produce 1 mole of OH. So MAVA is not gonna work out here because the number of moles of H plus produced is not equal to the number of moles of OH minus produced. Same thing here. If you dissolve 1 mole of each substance here, this will produce 1 mole of H plus because it only has 1 hydrogen per chemical formula, but CaOH2 will produce 2 moles. 1 mole of this substance will produce 2 moles of OH minus. Okay, so it's not, the number of moles of H plus and OH minus produced is not going to be equal. So in this case, you must use this formula here. You have to multiply the number of H's in the formula by the MAVA, and you must multiply the number of OH's in the formula by MBVB. We're going to see some examples where you have to do this. Okay, so again, this works out MAVA, MBVB if the number of H's and OH's are the same in the acids and bases reacting, right? If the number of H's and OH's are different in the acids and bases reacting, then you have to use this formula right here. Okay, so I have both formulas right here for titration, and I'm gonna do some examples. Alright, so let's look at this question here. If it says, the first one says, if it takes 45 milliliters of 0.1 molar NaOH to neutralize 125 ml of HCl solution, what is the concentration of the HCl? Alright, so we gotta figure out which one is the base, which one is the MA, which one is the VA, which one is the MB, which one is the VB. So you have circling the information that you are given is very important because you're not going to be putting the wrong value in the or substituting the wrong value for the wrong variable. Okay, so you have 45 milliliters of 0.1 NaOH. NaOH is going to be the base. Okay, so it's going to be this part of the formula. And then 125 ml of HCl. What is the concentration of the HCl? So it's asking for the concentration of HCl. We are given the VA, we are not given the MA. MA is the question mark. Okay, so now, which formula are we going to use? This one or this one? All right. This one is correct regardless of the number of hydrogens or OHs. So you could always use this one, but if you see that the number of OHs and the number of H's are equal, so you have 1 OH per formula here and 1 H per formula here, then you can use the formula given in the reference table. So to solve this problem, it's MAVA equals MBVB, MAVA equals MBVB. MA is the concentration of the acid, molarity of the acid, which is what the question is asking for. Right? The question is asking for the concentration. So it's going to be our X, or just leave it as MA. So it's going to be MA, and then VA is the volume of the acid, which in this case is 125 milliliters of HCl. So times 125 ml equals, the MB is the molarity of the base, which is 45 milliliters of 0.1 molar NaOH. So this is the molarity, 0.1 molar of the base. So 0.1 molar. And the volume of the base, which is VB, right, is 45 milliliters. 54 milliliters, excuse me. Okay, and like this, now you just have to either, you could start by multiplying these two, and then dividing the whatever you got by the 125, or you could isolate the MA, then do the division. That's what I like to do. Right? That's why my way. If your way is different, it's fine, because math can be done in different ways. So what I'm gonna do here is I'm gonna isolate the MA. So by dividing both sides by 125, okay, this ML, this here will cancel out, and I will get MA equals 0.1 times 54 divided by 125. Right, you do the calculation in your calculator, and 0.1 times 54 divided by 125, the answer is gonna be 0.0432. 0.32 what? Right, what's the question? What is the question asking me? It's asking for concentration. Right, so concentration, the units for concentration is molar. Right, notice I made a mistake here, which is not keeping track of the units. But if you forget to keep track of the units, you can always go back to the question to find out what you are looking for. So I'm looking for concentration. Concentration units is molarity, and this is my final answer. So MA equals 0.0432 molar. Next question. If it takes, okay, I'm gonna get rid of all the information here. If it takes 25 milliliters of 0.05 molar HCl to neutralize 45 milliliters of NaOH, what is the concentration of NaOH? So here you have to figure out which one is the acid, which one is the base, and then what you are asked to do. Right, so I'm gonna circle this information right here. 25 milliliters of 0.05 molar HCl. HCl is the acid, so this is our acid information, MAVA. And then to neutralize 45 milliliters of NaOH, this is our base information. Okay, and then the question is asking what is the concentration of NaOH. So this is the unknown. Concentration of NaOH, concentration of the base. Concentration of the base is molarity of the base, which is Mb. So the question is asking us to find Mb. So Mb is unknown. Okay, so using the formula, now you can either use this formula right here or the formula given to you in your reference table, right? You can, so since if you look at the number of hydrogens and OHs, they are the same. You have one hydrogen, one OH, so you can use MAVA equals MBVB, right? Or you could use this one here, number of H equals number of MAVA equals number of OH, MBVB, whatever you decide. Okay, but the chemistry reference table formula is sufficient here. So MAVA equals MBVB. All right. Now I'm gonna substitute. MA is concentration of the acid. What's the concentration of the acid? I circled the information for the acid here. The concentration of the acid is 0.05 molar. Right, and then VA is the volume of the acid. What's the volume of the acid? I circled the information for the acid here. See how easy it is for me to figure out the information that I need? The volume for the acid is 25 ml. Right, equals MB, which is, I don't have it. This is what the question is asking for, so I'm just going to keep it as MB. VB is given right here, information for the base, 45 milliliters. Alright, so again, you could do it your way or you could do it my way, whatever way you like. You could do the calculation. I'm going to isolate the MB and then do the calculation, but you could do it your way too. Okay, so to isolate MB, I'm going to have to divide both sides by 45 ml. Once I do this, I get MB is equal to 0.05 molar times 25 ml divided by 45 ml. Alright, so the ml units cancel out, and when you do the calculation here, it's 0.05 times 25 divided by 45. You will get, right, MB is going to equal to 0.02777 or 0.278. Right? You could round to the nearest thousands or hundred thousands. Doesn't matter. As long as you keep 3 non-zero digits, that usually makes a good number so that you don't make any errors. Okay. So don't just write 0.03. Make sure to keep at least 2 or 3 non-zero digits in your answer. So this is the answer here. Okay. MB is 0.0278, and then what's the units? MB is the molarity of the base, concentration of the base, so it's gonna be molar. Pretty easy stuff. Third question. You could try the third question on your own. I'm gonna do it in 2 seconds. Okay. If it takes 50 ml of 0.5 molar CaOH2 solution to completely neutralize 125 milliliters of nitric acid, solution HNO3, what is the concentration of H2SO4? Okay, there's an error here. This should say sulfuric acid. Instead of nitric acid, it's gonna be sulfuric acid. Okay, sulfuric acid, this is gonna be H2SO4, right? Why am I using sulfuric acid and not nitric acid? You're gonna see that now. Alright, so since I don't have space, I'm gonna erase whatever's on top, and I'm gonna use the space on top to do my calculation. Right, so right now you're gonna look at it and you're gonna be like, oh, the number of you have 2 hydrogens in H2SO4, right? You have 2 hydrogen H2SO. We have 2 OHs in CaOH2. But remember, if the number of hydrogens is the same in the acid is equal to the number of OHs in the base, you don't have to use this formula here. You can always use this formula. This here, you have to use it only when the number of H's and number of OH's are different in the acid and base. Okay, so you can either use this or this, whatever formula you like, but in our case here, the number of you have in H2SO4 there are 2 H's, in CaOH2 there are 2 OH's. So the number of OH's is equal to the number of H's. So it's okay to use the titration formula given in your reference table. So I'm gonna use that one. Okay, so I'm solving for number 3 now. Okay, let me circle my information. It says if it takes 50 ml of 0.5 molar CaOH2. Okay, I'm gonna circle this, and looking at the formula, CaOH2 is a base, so this is my base information. Alright, which is gonna help me when I substitute the numbers in the formula. And then here, neutralizes 125 milliliters of sulfuric acid. This is my acid information. The question is asking what is the concentration of H2SO4 solution. So this is MA. It's unknown. That's the question mark. Alright, so let me write the formula down. MA VA equals MB VB. MA is unknown. VA is in the acid information 125, so it's gonna be MA, or let me, oh my god, I don't know what I just did. Okay, I got it back. Okay, so I'm gonna start here because I need the space. So MA is unknown, which is the question. This is what we're solving for, right? MA is unknown, and then VA, the one I circled said 125 ml of acid, so the volume of the acid is 125 ml equals MB. The molarity of the base is, I circled the information here, 0.5 molar. VB, I circled the information here, which is 50 ml. Alright, so now doing it my way, I'm gonna isolate the MA, then do the calculation. So isolate the MA by dividing both sides by 125 ml. Okay, so now I have MA equals 0.5 molar times 50 ml divided by 125 ml. The ml units cancel out, and then when you do the calculation in your calculator, 0.5 times 50 divided by 125, you will get, the answer is MA equals 0.2. But 0.2 what? Okay, remember you have, or you should put the units. Okay, 0.2 what? You need to put the units. So the question, MA is concentration, so it's gonna be molar, and that's it. Now 4 and 5, this is where the numbers of OHs and H's are different from the acid to the base. Okay, so how many milliliters of 0.1 molar H2SO4 are required to neutralize 25 milliliters of 0.2 molar KOH? Alright, so I'm gonna circle my information here. Says how many milliliters, so I don't know the milliliters, but it's in the question. H2SO4 is my acid, this is my acid information, and then here the KOH is my base, so this is my base information. Now how many milliliters? The question is asking for VA, right? Volume of the acid, because right? And then now for this question, notice that it's H2SO4, so per each formula of H2SO4 there are 2 hydrogens. In KOH there is only 1 OH per KOH. So for this type of question you must use this formula right here, because the number of H's and number of OH's are different. Here you have 2 H's in the formula, here you have only 1 OH, excuse me. Okay, so let's do that now. So we're gonna use this because we can't use this if you use this formula, it's wrong. It's not gonna give you the correct value. Alright, so alright, let's start. So it's MA, so we're using this formula. I'm not gonna rewrite it, but you see it right here. It's number of H MAVA equals number of OH MBVB. Alright, so number of H's is subscript of 2, so it's going to be 2. I'm going to say it again because I don't want you to get confused. I'm using this formula right here now. Right, so I'm using this formula, I'm just not rewriting it. Okay, because it's going to take, because I don't have enough space here. So it's 2 H's, and then MA, from the acid information, it's 0.1 molar. And then VA, from the acid information, that's what the question is asking for, how many milliliters of the acid. So it's VA, I'm going to keep it as VA, equals number of OH's. Alright, so the base here only has 1 OH, so number of OH's in the acid is 1, times MB, concentration of the base is 0.2 molar, 0.200 molar, and then times volume of the base. In this case, the volume of the base from the base information is 25 milliliters. All right, now you're gonna isolate your missing variable, which is VA, and do the calculation. Otherwise, again, this is my way of doing it. I like to isolate before multiplying or before doing the calculation. Makes my life easier, I feel. All right, so to isolate the VA by itself, I'm going to divide both sides by 2 times 0.1. When I do this, these will cancel out. All right, and then I'm going to divide both sides again. So it's going to be 2 and 0.1. Okay, so once I do this, I get VA by itself. So VA is going to equal to 1 times 0.2 times 25 divided by 2 times 0.1. And now you just plug it into the calculator. So 1 times 0.2 times 25 divided by 2 divided by 2 times 0.1. Alright, so here for this type of question, remember to divide before you remember to multiply these before dividing. So you have to multiply 2 times 0.1 before you divide. Because otherwise you're gonna get the wrong. If you do 1 times 0.2 times 25 divided by 2, and then you multiply it by 0.1 right away, you're gonna get the wrong answer. You have to multiply these together before dividing. So 2 times 0.1, that will be 0.2. So now you could multiply the top and then divide by 0.2. Alright, so I'm gonna do that. So it's gonna be 1 times 0.2 times 25 divided by 0.2. Final answer is 25, or VA is equal to 25. 25 what? It's VA. The units here in the question used are ml, so it's gonna be 25 ml. This is the final answer. You could try this on your own. Let's see if I did this without multiplying the denominator first. Let's see what number I would have gotten, so that just in case you did it and you got something different. So 1 times 0.2 times 25 divided by 2 times 0.1, you would get 0.25, which is wrong. So you must do this calculation first, the denominator calculation, then multiply the top and divide by your results from the multiplication at the bottom, which is 0.2 for in our case. That will give you the correct number. Alright, so this was for question 4. Okay, let's do question 5 now. Alright. Okay, question 5 says, what is the molarity of hydrochloric acid of a hydrochloric acid solution 3 ml of which is just neutralized by 48 ml of CaOH2. I don't like the wording of this question, but it's still easy to get the information needed. So in this question it says 30 ml of hydrochloric acid, which is HCl, right? You could go back to your table K and L. 30 ml of HCl is used to neutralize, or is just neutralized by 48 ml of CaOH2. So this is our base information right here. So this is our base information, this is our acid information. Alright, so now you have the question, which formula do I use? This one or this one? to answer that, you have to look at the number of H's in the formulas and the OH's. So HCl has 1 H per HCl. CaOH2 has 2 OH's per CaOH2. Okay, so this has 2 OH's per formula, this has 1 H per formula. So when you see that the number of OH's and H's are different, you have to use this titration formula. Alright, so we're gonna use that one. So it's gonna be, so let's use that formula then. It's gonna be number of H's, MA VA equals number of OH's, MB VB. So number of H's in HCl is 1. MA, right, let's see what the question is asking. What is the molarity of hydrochloric acid? That's what the question is asking. What is the molarity of hydrochloric acid? It's basically asking what is MA. Right, so that's our variable, that's our unknown, so it's MA times VA. The volume of the acid is 3 ml equals to number of OH's. Alright, in CaOH2 there's 2 H's per CaOH2, so it's going to be 2 OH's times MB, the volume of the concentration of the base from the formula we from the information we circled in the question. It says 48 ml of 0.1 molar CaOH, so that's the molarity, 0.100 molar CaOH. And finally VB, right, from the base information it's 48 milliliters. Okay, so 48 milliliters. So now that I have all the information down, I have all the numbers down, all you need to do is isolate the missing variable. Right? You could do that, or you could start by multiplying and then dividing, whichever way you like. So I'm gonna do it my way. I'm gonna isolate the VA. I'm gonna do that by dividing both sides by 1 times 3 ml. Divide both sides by 1 times 3 ml. So this cancels out, so I get MA is equal to 2 times, or without the X, okay, 2 times 0.100 molar times 48 milliliters, I should say milliliters, right, divided by 1 times 30 ml. So 1 times 30 ml, remember you have to divide, you have to do this calculation at the bottom first before doing the top, because otherwise you're going to get the wrong answer. 1 times 3 ml is 30 ml. So now that I have only one number at the bottom, I can multiply and then divide normally. So it's going to be 2. So to answer this question, to do the calculation, is going to be 2 times 0.1 times 48 divided by 30 ml, and the answer, the final answer, is going to be 0.32. 0.32 what though? Right, so since the question here is asking for molarity of the hydrochloric acid, so it's going to be molar, and that's the answer. Right, so MA is equal to 0.32 molar. Right, and that's the concentration of the hydrochloric acid. And you're done. I know I have this strange M here. Alright, so I hope this was helpful. I know it's long, but I'm trying to provide extra help, and I'm going as slow as possible, doing every step, right, expressing my thinking as I do it, and I hope this was helpful. For the questions I'm going to ask you, most of them are going to be these type of questions. You might see some of these questions though. Right. I did give you practice in the test wizard, so please go do it, or you could do it again. You also have the surviving chemistry practice, you could do that too, right? And it also has more notes and explanations. You could always go back to that puzzles. And yeah, I hope this was helpful.